first node that we're going to look at is the transform node. As you would expect, this is a very simple node, but that makes it a good candidate to explain some of the clever things you can do with Houdini. In fact, in playing around with this node, I realised that I can use it to reproduce one of the most time-saving tools from my first job, baking shops and houses for the game The Getaway. So in honour of this, I'll be demonstrating the transform node with some house models, in this case Dutch houses made with a procedural Dutch house generator. I would encourage you to follow along with this tutorial and try to reproduce it. You can also use any roughly symmetrical model as an input, but I've provided some Dutch houses to try out. Open up an empty scene, right-click in the OBJ network and type Geometry to create a geometry node. Double-click this node to open it, and inside you will see a single file node. This is the default node inside a geometry node, and usually we would delete it and replace it with something more appropriate, but for this tutorial a file node is what we want. To bring up the node selection menu, either select the file node and hit Tab, or right-click on it, and this will bring up the Tab menu. If you right-click on the little circle output connector at the base, it will automatically connect up the node that you select. In the Tab menu, you can either search by category or by typing to find the node you want. The Tab menu uses fuzzy searching, so you can be quite creative about what you type. You can type the first letter of each word, for example. Say you wanted to find attribute wrangle. If you type the word attribute, you'll get a long list of results. But you could just type AW and it will take you straight to the correct node. Sometimes you'll have to type the first two letters to get the right one. In this case, we want the transform node, so type TRAN to bring it to the top of the list, and then hit Enter. When you click in the network view, it will create a transform node connected to the file node. Now click the blue display render flag on the transform node, which will make it render, or cook, as far as this node in the viewport, and select it to make it active. This will open up the transform parameters box. Before we get into looking at this particular node's parameters, I want to show you some useful shortcuts for working with parameters in Houdini. First, we have the number ladder. If you don't want to type a value into each parameter, you can middle mouse click, and this brings up a column of numbers which we can scroll up and down through. This way we could quickly access values with high and low degrees of precision, which is useful for moving objects a tiny amount or a very large amount. We can apply this to each value separately, or we can edit the whole row at once. Many Houdini nodes start with a group parameter. This is used when we only want to apply the node to a subset of the input geometry. The rest of the geometry will pass through unchanged. Currently, there are no available options in the drop-down for the group because the file input doesn't contain any groups. We could, for example, add a group node between file and transform, which selects only upward pointing faces, and call this group up. Now the group is available in the transform node, and any changes that are applied only to that face. If we put an exclamation mark in front of the group, it will invert it and only apply changes to the faces not in the group. Let's delete that group node and go back to the original file. You can see if I delete the group without removing the up group option, we get a little yellow exclamation mark next to the transform node. In order to find out what that is and to get information about a node, use the middle mouse button to open up an information box, which tells us all sorts of useful things about this node. At the top we find out what the exclamation mark is about. This is a warning that up is not a valid group. If we remove the up group from the options, the warning disappears. Next, we have a list of information about the number of components and measurements for the geometry passing through this node. Then we have a list of attributes for each component this node contains. point color attributes represented by CD, position attributes represented by P, normal vertex attributes represented by N, and one detail attribute. Detail attributes are a single attribute applied to the whole geometry. Normally you would see a list of groups next, but as we've just removed the only group attached to this node, there are none. The time-dependent no shows that this node doesn't contain a simulation. Underneath that, there's some general information about its properties and cook status. In Houdini, cooking refers to the processing of each node one after the other from the top of the network as far as the currently rendered node. Hence the name of these tutorials, Houdini Kitchen. One more thing that's very useful to know and applies to all Houdini nodes is that in the top right of the parameters pane there's a help button which links you to excellent documentation for each node, which explains the function of every parameter. These documents are not just a learning tool, but essential reference for anyone using Houdini. They often contain downloadable example files which are a really intuitive way of learning what a node can do. Now let's take a look at some of the parameters on the transform node. The parameters themselves shouldn't need a lot of explanation, as you'll see similar properties on a transform node in any 3D modelling program. To look at some of the other less common ones. The Move Centroid to Origin button is a one-off action that will adjust all the parameters to move the object to be centered at the origin. This isn't very helpful in a procedural network because we don't want to have to go in and hit that button, but there are other ways of getting the same result which we'll look at later. The asterisk in the attributes dialog is a wildcard shortcut to tell the node to transform all the attributes. If you select the drop-down arrow, it will show you which attributes are being transformed, normal and position. If we were to rotate the model and then remove the asterisk, there would be no visible change to the model because the object points are no longer being transformed. If we select the position P, the geometry is once again transformed, but the normals are not. As you can see in the viewport, the lighting is no longer correct. Switch on the normals display to see what's happening, and you can see that they are at odd angles. Type N or replace the asterisk to turn them back on. Recompute point normals recalculates the normal direction for each point. An important and slightly confusing element of Houdini, and a difference to most other 3D programs, is that points and vertices are not the same thing. Most of the time you'll find yourself working with points, but each point only has a single attribute, so point normals will always give a rounded edge and point colors will always blend into each other. In order to get a hard edge, the normals should be applied to the vertices. Each point can have several vertices, one for each face, so we can think of a vertex as a point per face. If we turn off recompute point normals again, you can see that there are now 3 normals for each corner as you would expect. We will go into the difference between points and vertices in more detail in future tutorials. Invert transformations is a handy little button if you want to undo the transforms you've made further up the chain. Make a copy of the transform node with invert transformations and apply it further down the chain. Even better, we can make a reference copy of the node. Right-click, Actions, Make Reference Copy. This will link all the parameters of the first node to the second. You can see the links, and the green background tells you that these parameters are being driven from somewhere else. Control and left-click will break the link. If we break the link to invert transformations and then turn it on, we now have a live undo for the original node. A handy hint, if you want to reset all the parameters, is to click the little gear at the top right and revert to factory defaults. Now I'm going to bring in one of those Dutch houses. Use the file node to reference in dutchhouse1.obj. This model was not built centered around the origin, and the height and width are not at the correct scale. If you don't want to download the file, you can use any model that doesn't sit at the origin. Being off-center is not very helpful when we're laying things out in a scene. In games, models in an asset library sometimes have to be built to a limited number of fixed dimensions, have the pivot at the center bottom of the model, and sit at the origin. Doing this in Maya would take quite a few lines of Mel script. I'm going to show you how to do it in a single node in Houdini. First of all, create a clean new transform node, or use the one where we just restored the factory defaults, and plug the building into it. What we want to do first is move the building so that its geometric center is at the origin. To do this, we use Houdini local variables. Historically, these started with the $sign, but as the VEX language has developed in Houdini, some of them have been updated to use an @ prefix, because this is how we refer to variables in VEX. The documents will show you both types where they exist. Try typing a $sign into one of the translate dialogues, and you'll see a drop-down list of variables. Some of these are local variables which are specific to this node. Others are global, such as the frame rate or file path. To find out which local variables are available for a specific node, open the help again, and you can see it has a list of all the variables that you can access. The variable we need first is the world transform of the object center point. Type CEX into the dialog box after the $sign. The object will move, but will actually move further away from the origin. This is because we just took the X distance of the center of the object from the origin and moved it away by that much again. What we actually want to do is invert that distance, so add a minus sign in front of the $CEX. Now the object should be in line with the X coordinate of the origin. Do the same for all three translate dialogues with the appropriate X, Y, and Z variables. You'll notice as you type there's also an option for CEY2, CEZ2. If we had two inputs in this node, this would reference the center point of the second input, but in the case of the transform node, it's not relevant. Now our building is sitting with the origin at its center. This will work on any object. Try plugging in one of the other buildings to see. Now we want to lift the building up so that the base sits on the grid plane. We need to lift up the object by half the object height, and there's another local variable we can use to do this. The $size variable returns the maximum size of the bounding box in each axis. So we add the size variable times 0.5 to the Y transform. Now the building sits on the grid. We also want to restrict our building to a predefined collection of widths. To start with, let's make it 1 meter wide. We can get the width of the bounding box with $size. If we invert this value and put it in all the scale dialogues, the result is a building that fits exactly inside 1 meter cube. This might be useful for some types of asset, but in the case of the building it's pretty distorted. We actually just want it 1 meter wide and proportional in the other dimensions, so divide all the scales by the size X variable. We want to allow several different widths of buildings. To choose a width, we'll create our own fixed width parameter. Click on the gear symbol at the top right of the parameter editor and select Edit Parameter Interface. Let's use an ordered menu, which lets us choose between a list of values. The parameter interface editor has 3 sections. On the left is a list of all the different types of parameter we can use. In the middle is a pane containing the parameters belonging to the current node, which may be separated into folders or for different tabs. It will have all the existing transform node parameters there already. On the right is where we edit the settings for each parameter. In order to add parameters to the interface, we drag the type from the left-hand side to the folder structure in the middle. In this example, we'll drop the ordered menu into the root and it will appear at the bottom of the parameters when you hit enter. Open up the Menu tab. Here you can see a table of tokens and labels. The token is the value you send to the node. The label is what the user sees. We're going to make 3 options. Type 3 into token and 3M into label and hit enter. Do the same for 4M and 6M. Hit apply and the buttons appear. Go back to the parameter tab and give the menu a meaningful label and change the name to something similar. This isn't necessary, but it will make your life easier in future if your parameters are easily identifiable. Hit accept to save and close the window. Now to get our token value into the transform scale, we can access the value of any parameter from any other. There's a simple expression to do this, but we don't have to remember it because Houdini will create it for you. Right-click on the label of the menu and select Copy Parameter. Then right-click in the X scale box and select Paste Relative References. The values are now linked. We can use this little expression inside any other expression, so we can multiply it by the formula we already had for each scale value. Any building that we plug into this node will now be correctly placed at the origin and fit to the scale that we give it. Let's take this one step further and save it as a tool that we can use in another program. First, we have to turn this network of 1 into a subnetwork. To do this, use the button that looks like a loaf of bread. I think it's actually a picture of a box. This packages up our selected nodes into a single node with input and output connections. Open it up and you'll see your network of 1 inside, with an input that links up to the outside. The output of the subnetwork is the inside node with the blue render flag turned on. To save it to the disk, right-click and select Create Digital Asset. You have 3 options here: operator name, operator label, and library, which requires a file path and file name. Give it something meaningful and make sure it's being saved in a logical place. I like to use the same name for all 3 to save confusion, but in a team environment you might want to go with the Houdini suggestion of adding your username to the operator name. You're now presented with a window with lots of tabs. We'll cover all these in a later tutorial, but for now, open up Parameters. We see a parameter editor exactly like the one we used to add our set width parameter to the transform node. This allows us to add parameters to our digital asset to drive settings inside the node. When we access the digital asset in Maya or UE4 or Unity, this is the only way we can edit it. So in this case, we want to access the different widths. Leaving the window open, double-click the subnet to open it up and select the transform node. Find the fixed widths parameter and drag it into the middle pane of the window. This does 3 things. It copies the menu parameter and settings to the subnet. It hooks up the old menu to this new parameter, so it's now driven from the subnet. And it tells the subnet that it is driving the parameter fixed widths inside. Save and close the window with the accept button and the digital asset is complete. You will see that the subnet now has a little lock next to it. This means it's saved to the disk and you're able to make changes. If you make any edits to the subnet, right-click and select Save Node Type to update it on the disk. If you have the Houdini Engine plugin set up for any third-party software, you can now import this asset to help you clean up your model transforms. We'll cover digital assets in a lot more detail in another tutorial. There's a lot more cool stuff you can do with them. I hope you've enjoyed this tutorial. The next node we will be covering is the grid.